sequences and series. Sequences and series. Students, I believe we have in one way or another have had an interaction with this topic, sequences and series, whether directly or indirectly, from your primary school mathematics and your secondary school mathematics. In the sequences and series, we shall look at two main parts we call the arithmetic sequences and series and geometric sequences and series. So I believe by the end of the lesson today, we shall have had an understanding of what sequences and series are and how we shall be able to handle arithmetic and geometric series and sequences. To start us off, students, we need to have an understanding of this word, a sequence. In the simplest way, as we present or as we've heard it before, there is a meaning of a sequence as used in mathematics. Just as I've said that this is not something new coming in high school, but rather it's something that is drawn even in your primary school mathematics, where you discuss something to do with patterns of numbers. For instance, you must have heard there is a certain order we may develop when we have numbers arranged in this form, like 1, then the next number I write 3, the next number I write it to 5, the next number I write it to 7, to 9, to 11, to 13. So with this kind of order, it is easier for me to identify what exactly are we doing to these numbers to identify the next or the subsequent number. If you identify that particular number that is helping you to tell the next number, it tells you then it is easier to get not just one, but more than one subsequent numbers in that particular pattern. And that is why always when you're discussing about sequences, we refer to what we call the number patterns. We refer to them as number patterns. How have the numbers been arranged in a particular set of information? We could have maybe another one. This could be increasing pattern. Someone will give you this kind of a number or a pattern. Let's have 38, 35, 32, 29. Then you're given another chance to identify the following numbers. If you have this kind of numbers, again, this will be a decreasing sequence. So you will be able to tell what is being subtracted from this to get the next number. Now this kind of arrangement of numbers, we refer to them as sequences. We could have another design of arrangement of numbers. Let's perhaps talk of this one. We have a number like 3, then we have 9, then we have 27, we have 81, we have 243, and then there is a gap in between for you to identify the next number. If you compare the first two sequences and the third sequence, you will realize there is some distinction between the three. The first two are in the right or in the same order, while the third one takes a different form that we need to identify which form is this. Like, for example, if I consider the first one, I will easily say that I'm adding 2 to get the next number. In the second one, I'm subtracting 3 to get the next number. But the third one is not easy to say that you are subtracting or you are adding a certain number. Why? Because if you try, 9 less 3 is 6. 27 less 9 is 18. 81 less 27 gives you 54. So you find it is not as it is with number 1 and number 2. That's why we have what we call the types of sequences.
we have what we call the types of sequences. These that we are calling number patterns, they are grouped into two main types. Who can tell us from the previous discussion, what are the two types of sequences, students? Right. The two types of sequences are arithmetic sequence. We have arithmetic sequence, and then we have two geometric sequence. Geometric sequence. The two types of sequences, students, are arithmetic sequence and geometric sequence. Who will then help us to tell the difference between the arithmetic sequence and geometric sequence, students? Right. The arithmetic sequence is characterized by what we call the common difference. This one has or is characterized by what we call the common difference. How do we denote common difference, students? Good. We denote common difference by the letter D. We denote the common difference by the letter D. And the geometric sequence, this one is characterized by what we call the common ratio. Common ratio. And how do we represent or denote common ratio, students? Good. We represent or denote it by letter R. Another thing that you need to know, students, if we are looking at number patterns, it means we can be able to identify the order of numbers in that particular arrangement. And whenever there is an order of numbers in any particular arrangement, there has to be what we call the positioning of terms. So how do we represent the first term in any sequence, students? Good. We represent the first term. We represent the first term by the letter A. Similarly, at this point, we represent the first term by a letter A. Good. What if we are discussing as an infinite number of terms? An infinite number of terms that maybe is defined by a particular order based with the question. Then we use the letter N. Good. So we'll say the number of terms is represented by N. Again, at this point, the number of terms is again represented by N. Very good, students. These are the two types of sequences. Now let's go back to our number pattern and let's consider the first one. And I want us to be very keen, students, and do the counting. 1 is the first term. So we'll give it letter A if we are to represent the first term in this case. 3 is the second term. 5 is the third term. 7 is the fourth term. 9 is the fifth term. 11 is the sixth term. 13 is the seventh term. Very good. Now, what is the representation of the common difference? Good. Common difference is 3 minus 1, which is 2. And it is equal for all of them. Whether you take 13 minus 11, the answer is still 2. If you take 11 minus 9, the answer is still 2. So we represent 2 as our D. But now I want us to be very keen and say that if we can be able to order and number these terms from the first up to the seventh term, there is possibility that I can be able to identify maybe the 10th term, the 20th term, and so on, based with this particular order. However, if we are to follow this order maybe in a certain way and find that we are having more than 50 terms, it will become so much hectic to identify the next term. Therefore, we have a formula to determine the number of terms in an arithmetic sequence. So we say when you're given an arithmetic sequence, the number of terms solution of a formula, we say it's A plus n less 1 multiplied by D. A plus n minus 1 multiplied by D. Where, in this case, where the value A represents the first term. A represents the first term. N represents the number of terms. N represents the number of terms. For example, if you're looking for the 10th term, then n is 10. The 5th term, then n is 5. The 12th term, then n is 12. N represents the number of terms. D represents what we call the common difference. Represents the common difference. D represents the common difference. So let's look at an application of this formula using this example. Let's look at the application of this formula using this example, students. And you're told the first term of an arithmetic sequence, the first term of an arithmetic sequence is 5. And you're told determine the 8th term. Determine the 8th term given that the common difference is 3. Given that the common difference is 3. Students, our example is the first term of an arithmetic sequence is 5. We are told to determine the 8th term given that the common difference is 3. So how do we start it off, students? Assuming you have this question in an exam, where do you start? Good. First is to identify the formula. So what's the formula? Our solution. What is the formula? Right. Nth term is A plus n less 1 D. Right. That's step 1. Step number 2. We'll try step number 2. Good. You identify whether the question has any of these components here in the formula. And let's see. Our first term is A. Therefore, A is 5. The common difference is D. So our D is 3. And we are looking for the 8th term. So that means n is 8. Therefore, we have all the components in the formula. Now, what do we do? Right, we substitute into the formula. So we shall say our 8th term will be A is 5 plus, open the brackets, n is 8 less 1. What is the common difference? 3. So this becomes 5 plus 7 times 3. And what's the answer, students? Use your calculator as well. 5 plus 7 times 3, 26. Our answer is 26. So it means that the 8th term of this sequence is 26. Let's have the second one. We're told that we determine the 10th term of an arithmetic sequence whose first term and the common difference are 32 and 2 respectively. Determine the 10th term of an arithmetic sequence whose first term and the common difference are 32 and 2 respectively. 32 and 2 respectively. Good. Where do we start, my students? Where do we start? This is the question you have in your exam, and you have to answer the question. Where will you start? Right. The first step, identify the formula. So let's write the formula down. Nth term is A plus n less 1 times D. Step number 2, students. Yes, identify if there are any components in the question relating to the formula. And so let's go back to the question. We are told to determine the 10th term. So what's that? Right, that is n. Our n is 10. Whose first term? What's that? A. Good. That's our first term, 32. And the common difference, what's that, students? Right, that is D, is 2. Fine. Then next step, we substitute into the formula. So we'll say the 10th term equal to A is 32 plus 10 less 1 times 2. So this is 32. 9 times 2. So this is 32 plus 18, and the answer is 50. Therefore, the 10th term of our second sequence is 50, 50 as represented on the board. Up to that point, who has a question, students? Right. So my question will be, what is a sequence, students? What is a sequence? Yes, a sequence simply refers to number pattern. Good. What are the types of sequence? There are 2 types of sequences. Which one and which one? Arithmetic sequence and geometric sequence. Good. What defines the arithmetic sequence? Good. The arithmetic sequence is defined by the common difference, which is the difference between the second and the first, or the third and the second subsequently in that order. Therefore, if you are given a question to handle or to identify the nth term of an arithmetic sequence, you will apply the formula A plus into bracket n less 1 multiplied by the common difference. Very good. So let's now analyze the geometric sequence. What did we say geometric sequence is, students? Good. We said it's a sequence that is characterized by what we call the common ratio. Now, let's get to that point, that the geometric sequence has what we call a common ratio. And so, what is this common ratio? What is this common ratio? So, we are looking at geometric sequence. Geometric sequence. And we are saying that in a geometric sequence, this one has what we call, has a common ratio. And how do you represent the common ratio? Represented by R. The common ratio is denoted by R. So whenever you see R, it simply implies the common ratio in this topic. Now, what is the common ratio? The common ratio, our common ratio, is the ratio of the second term to the first term. The second term to the first term, and which is the same as the third term over the second term. And we can continue writing the fourth over the third, fifth over the fourth, and so on. It forms what we call a proportion. That is what brings out the common ratio R. And that, just like in arithmetic, we'll be required to identify the position of terms in any particular sequence before we can be able to use that numbering to identify what is the common ratio and so on. Now, in this case, how do we identify the nth term in a geometric sequence? How do you identify the nth term, students? Good. We say the nth term equal to AR power n minus 1. AR power n minus 1. Where A represents the first term. A represents the first term. R represents the common ratio. And N represents the number of terms. Therefore, we have the formula AR power n minus 1. And we're saying that A is the first term, R is the common ratio, and N is the number of terms. Therefore, in this sequence, we have two formulas. One, how we identify the common ratio, and two, how we identify the nth term. Putting it in practice as an example, if we put this as an example, you're told to find the sixth term of a geometric sequence whose first term is 2, and the common ratio is 3. So we find the sixth term of a geometric sequence whose first term is 2 and the common ratio is 3. So let's start solution. We are saying we have the sixth term that defines our n is 6. The first term that defines our A is 2. The common ratio represents our R, and that is 3. The question is, we identify the sixth term. So we are saying that the nth term equal to AR power n minus 1. The nth term is equals to AR power n minus 1. A is the first term. So we shall say our sixth term is A2 into R is 3 power n is 6 minus 1. So what will this be? 2 into 3 power 5. So we shall need to use our calculator, students. So take out your calculator, students, and let's do the representation of these on our calculators. let's work out this using our calculators. So we have 3 power 5. 3 power 5 simply means 3 5 times. So that gives us 729. Then we multiply by 2. So the answer is 1458. 1458. Therefore, the sixth term of this sequence will be 1458. It will be 1458. So once we have this solution, students, then we will now be able to confidently say that we have identified the sixth term as per the question that we have. So we can look at the second example. Let's look at the second example and see how to illustrate this concept of geometric sequence before we make progress to another scenario. Question number 2. Determine the eighth term of a geometric sequence whose first term and the common ratio whose first term and the common ratio are -2 and -2 and 4 respectively. -2 and 4 respectively. We identify or we determine the eighth term of a geometric sequence whose first term and the common ratio are -2 and 4 respectively. That is the question. Who will lead us now? Step 1. Right. Step 1 is to identify the formula. Good. So what is the formula for the nth term? Nth term. Right. The nth term is a r power n minus 1. Step number 2. Yes, step number 2. Identify whether the components given the question correspond to any of the characters in the formula. And in this case, the nth term means that our n is 8. Our first term, that is a, that gives is -2. What about r? Our r is 4. Step number 3. Good. We substitute this into the formula. So we shall have -2 into r is 4 power, what is n? 8 minus 1. That gives us -2 into 4 raised to power 7. Then we take out our calculators. So all students take out their calculators as we work out this. Make sure you have your calculator on. Substitute in the figures. 4 power 7, what does it mean? It means 4 7 times. So what is that? That is 16,384. 16,384. Then we multiply by -2. So the answer we have times -2, 32,768. but negative. 32, 768, but negative. So that is how we get the nth term in a geometric sequence. The nth term in a geometric sequence. So we can get now to another example. We can do as many examples as possible in relation to this, and then be able to see the trend, how it appears to be in the geometric sequence and in what we call the arithmetic sequence. Any questions, students? Yes. The question is a geometric sequence. Yes, a geometric sequence, we said it is simply a sequence that is characterized by the common ratio. That is what differentiates it from the arithmetic sequence. Another question? Good. We identify the nth term of a geometric sequence by applying the formula, AR power n minus 1. This is the formula that you said for nth term in what? In a geometric sequence. Please do not confuse this one with the earlier formula. We wrote the earlier formula at the arithmetic sequence, and we said that in the arithmetic sequence, when dealing with arithmetic sequence, then the formula for nth term, we say it is a plus n minus 1 d. And now we are saying for the geometric sequence, the formula for the nth term is a I power n minus 1. Good. Any other question? No question. Fine. So let's now make progress. Let's make progress, students, and discuss something we call series. We discuss briefly what are series, because the topic is about sequences and series. So we want to see how are series connected to sequences. How are series connected to sequences? How are series connected to sequences? What is a series? You've heard people say they're watching series. What could this series be? And bring it in mathematics, students. Series is simply the sum of terms in a sequence. Good. A series is simply the sum of terms in a sequence. Good. The sum of terms in a sequence. For example, we say this is a sequence. We said if I have 2, 5, 8, 11, this is a sequence. This is a sequence. The pattern of numbers. But now when it comes to a series, what it means is you sum the terms in a sequence. So now this becomes 2 plus 5 plus 8 plus 11. Do not write the answer, because this is simply a representation of a series. So a series is simply the sum of terms in a sequence. And I'm saying do not make a mistake and say the answer here will be 2 plus 5 is 7, 15, 26. It's wrong. We are only representing this using the addition sign for you to know one thing, that a series is the sum of terms in a sequence, whether it is geometric or it's arithmetic. In this representation of series, we are going to use a word we call progression, because it's like we're saying we are making progress of certain terms in a sequence, or we are getting the progressive sum of the terms. And that is why series are also referred to as progression. We also use the word progression. Therefore, we have what we call a progression or a series as concerns to the order of sequences. Let's have somebody try this question. You are asked, what are the types of series? We'll try. What are the types of series? Good. How many are they? There are two. Which one and which one? Very good. There is geometric series, which is derived from geometric sequence, and arithmetic series, which is derived from arithmetic sequence. Very good. Let's write them down. Types of series. Types of series. Types of series. Number one, we say you have arithmetic series. An arithmetic series is also referred to as an arithmetic progression. Also referred to as arithmetic progression. Who has an idea how do we represent arithmetic progression in the simplest form? Good. We represent them as AP. So when you see AP, it simply means arithmetic progression. Good. The second term, the second type of a series, we've said it's referred to as a geometric series. Good. We have what you call a geometric series. Another word for geometric series, geometric progression. Good. Geometric progression. How do we represent geometric progression, students? How do we represent it? Good. We represent it as GP. So when you see GP, that's a geometric progression. circumstance you find that R is more than 1, then you apply the first form. Where R is less than 1, you apply the second form. That is how we represent the sum of terms as series. And we will be able to look at the examples in our next lesson to see how do we apply sequences, series, or progression to a particular continuous equation. So for today, students have been able to discuss the topic sequences and series, and in particular, we've had an emphasis on what we call a sequence. We say that a sequence is simply an order or an arrangement of numbers in a pattern. And we've discussed two types of sequences, the arithmetic sequence and the geometric sequence. For each of the sequences, we've been able to see examples of determining a certain number of terms in that particular sequence. What we should have mastered as a principle is that the determination of any number of terms in any sequence is based on a particular formula. If it is geometric, we'll say it